Hello everybody, welcome to Virtual School Physics is Fun. This is Puan Liao here. Today Puan Liao is going to share with you forces acting on a pulley system. Now the pulley that we are using is a smooth pulley, meaning there is no friction between the pulley and the rope that is placed over it. If we were to tie a load onto the one end of the rope and then the other end we just hold it, and we want to pull the rope so that the load is lifted up and then stationary and then stay stationary. How much of force do we need to pull on this end so that the load is remaining stationary, is resting here without any motion? Okay, of course, we need to pull it with the force that is the same as the weight of the object here. Yeah, so the force that we need to apply on it will be the same as the weight of the load so that it remains stationary. Okay, so I stretch the rope, I straighten the rope so that we can see the forces acting on the rope. So the force is acting on the right and the weight is on the left. So force will be equals to the weight because there is no motion. Now the second case is if I hang two loads onto the end of the rope, one is heavier than the other. Let's say M1 is heavier than M2. Okay, what are the forces acting on the system? M1, mass 1 will have the weight acting down, W1. Yeah, W1 will be the weight of mass 1. And W2 is also acting down because it's the weight of the mass of M2. Yeah, both of these are the weight that is acting towards the center of gravity. So if I let go of these weights, obviously the heavier weight will come down, will move down, whereas the lighter weight will move up. And because the two of them are tied with the same rope, so they will move with the same acceleration, but one moving downwards, the other moving upwards. So what is the net force of this pulley system? So in order to understand this system better or easier, I straighten this rope. I stretch out this rope and straighten it. Okay, so by stretching it out, we can see clearly that W1 and W2 are of the opposite direction. And the system is actually accelerating to the left. Yeah, so you see here this rope, if I stretch it out, I stretch it out, so this is moving upwards, this is downwards. So when it's stretched, so the system is moving, accelerating to the left. Okay, so by using Newton's second law, F equals to ma, right? This F is actually F net. So A is to the left, right? A is to the left and F is always the same direction as A. So it's also to the left. So the net force is to the left. W1 is to the left. So W1 is to the left, so it's positive. But W2 is to the left, to the right, so it is negative. Therefore, F net will be equals to W1 plus minus or plus the negative W2. In short, it will be W1 minus W2 equals to the mass. This net force acting on the mass to make it accelerate. So in this case, both the masses are moving, right? Both the masses are moving. Therefore, this M is the sum of the two masses. Yeah, the mass of both of these loads. Okay, so M1 plus M2 times A. Understand? Okay, so W1 minus W2 equals to M1 plus M2 bracket A. Let's look at some concrete example. So I have a pulley system, a smooth pulley. So with M1 8 kg, M2 only 5 kg. So when I let go of the system, what happened? Of course, M1, which is heavier, will accelerate down. M2, which is lighter, will accelerate upwards. Both will accelerate with the same acceleration. How much is this acceleration? Okay, so let's learn to calculate this acceleration. Yeah. Now, first and foremost, I stretch this rope so that it is straightened. Okay, straighten the rope, and I see that the weight of M1, which is 80 Newton, is acting to the left, whereas the weight of M2, which is 50 Newton, if we were to take G, gravitational acceleration as 10, so it will be 50 Newton to the right. So what is the net force? Net force will be to the left, right? Net force is 80 minus 50, which is 30 Newton to the left, because the acceleration is to the left, right? So this whole system, this is moving down, this is moving up. Okay, so the whole system is moving to the left. When we stretch out, we can see it very clearly. Okay, so if we take the system as a whole, as one whole system, so F net equals to MA. Now, F net is to the left, so W1, which is 80 Newton, is to the left. W2, which is 50 Newton, it is to the right. Yeah, so we have to minus. So 80 minus 50 is our net force, equal to M. M is the mass that accelerate with A. Because both masses also accelerates, therefore this M is the sum of both of them. So 8 plus 5. 8 plus 5. Okay, so we have 80 minus 50 equals to 13A. So from here, we can calculate A equals to 2.31 meter per second square. Clear? So this is how we can calculate the acceleration of the system. Now, if you look closely, this system, there is also another force that is acting, which we call the tension. Yeah. So the rope becomes tight when you tie a load onto it, right? So the rope becomes tight. So the tightness of the rope is tension. Yeah, tension of the rope. So because these two ropes, this rope is actually one rope, yeah, continuous rope. So the tension T1 over this side and the tension T2, they are actually the same because they are of the same rope. So T1 is actually equals to T2. But how do we calculate this tension? So we can calculate by taking only one load, one side. Yeah, by taking only one side. Let's say we take the M1, the load of M1. We only look at the system M1. So F equals to MA. What are the forces acting on M1? So it is the weight acting downwards and the T1, which is acting upwards, right? So weight is 80 Newton. T1 is acting upwards, so it's negative. So 80 minus T1 equals to MA. The M is the mass. So since we are only taking one side, so the M is only the 8 kg. Yeah, we are not taking this side. We are taking one side by side. If we want to calculate the tension. Okay, so this M is only 8. So 8 and then times the A that we have calculated. So through this way, we can calculate our tension of the rope, which is 61.52 Newton. And as I mentioned just now, T1 is equals to T2. Okay, so this is the way to find our acceleration and the tension of the rope. Okay, but there is also another way. So if we were to take the whole system, take the whole system as 1, and we will see that and we take side by side, take the one side by one side. Just now on the left side will be 80 minus T1 equals to 8A. 80 minus T1 equals to 8A, right? Because this system is moving downwards, so W1 is same direction, so W1 is positive. T1 is opposite direction, so is minus, equals to 8A. So this first equation, we derive it from the system, the system on the left, that is from the mass M1. Now, what about M2? So M2 is moving upwards, So by using F equals to MA2, the T2 is in the same direction as the net force, upwards. So T2 is positive, but the W2 is negative. Therefore, we have T2, it's actually T, we don't have to differentiate it now because I say T1 is equals to T2. So T minus 50 will be the net force for this left side, right side, sorry. Okay, so T minus 50 equals to MA. So the M is 5, only taking the right side. So M is M2 only, so it's 5A. So we have another equation. So we have two unknown, that is A and T. So we have two equations. So we solve them simultaneously. Then that will give us the A and the T. Alright, so this is an alternative method. Okay, so if you take side by side, and you will have the alternative method. But if you take the whole system as 1, your T1 and your T2 does not exist because T1 and T2 is cancelling out each other, right? So T1 is acting this way, T2 is acting that way. So T1 will minus off T2. So it will not appear in this equation here. Okay, so we only have one unknown, so we can calculate A. Then after that, we take the system side by side to calculate the T. Alright, we will end here for Pulley system, part 1. So we will continue with part 2 of Pulley system. Okay, I'll see you again. Bye. Thank you.